Here we're going to look at our last financial application. We're really going to look at two different things, but first we're going to consider borrowing models. And for borrowing, so here you're taking out a loan, the loan will accumulate interest. The interest accumulation and the resulting value of the loan can be modeled using the same interest models we've seen, depending on if it's simple interest or compound interest. So A equals P times 1 plus RT for simple interest, where P is the initial amount, R is the rate, T is time, and the rate and time share the same units. Or if it's compound interest, P equals 1, or A equals P times 1 plus I to the N, where I is the periodic interest rate, N is the number of periods, and if everything is in years, that equals P times 1 plus R over M to the MT, where R is the annual rate, M is the number of compounding periods per year, T is time in years. So let's look at an example of this. You take out a loan of $5,500 on September 1st, 2016. The loan accumulates interest at an annual rate of 4.29%. 4.92. 4.29%, and this is going to be billed quarterly. So 4.29% per year, but it's billed quarterly, so a quarter of that will be the quarterly interest rate. And the question will be, how much do you owe on December 1st of 2020? So we have a loan, $5,500. That should say September 1st. September 1st. I think the 1 and the slash must have intersected. You take out a loan, $5,500 on September 1st, 2016. The loan accumulates interest, annual rate 4.29%. Billed quarterly. How much do you owe on December 1st, 2020? So first, note that the interest is billed quarterly. So we're going to first find the quarterly interest rate. Quarterly interest rate, 4.29% per year, divided into 4, because there are 4 quarters in a year. And this equals 1.0725%. Okay, so now this is just simple interest, so we need and you could have used the annual interest rate and then convert it into years. That probably would have been easier with fewer numbers. But I'm going to convert everything to quarters because I already started that. I'll just keep going. So how many quarters have passed? Well, September of 2016 until September of 2020, that's 4 years. And then it's 3 months more than 4 years. 4 years, 48 months plus another 3 months. Tells us 51 months have passed. And how much is that, how many quarters is that? Well, 51 months, I should put units on this, 51 months times month in the denominator. Sorry, that says MO in the denominator. Quarter in the numerator. There are 3 months in 1 quarter, so divided by 3. And this equals 17 quarters. So here we have quarterly interest rate, we have our number of quarters, so we can figure out the amount that the loan is worth. 5,500 times 1 plus 0.01075 times 17. And this is approximately $6,502.79. So if this question did ask how much interest, then, well, you would just need the PRT, computation for interest, and you get $1,002.79. But this same exact question could have been phrased in terms of the other application of interest where we were saving money at a certain interest rate. So let's go to a new page. Okay. So we have some information on borrowing. We're going to combine what we know about borrowing and what we know about payment from last week. We learned, I guess that was, I forget if that was last week or the end of week 11. But here, I'll just note, we combine borrowing and payment to find a periodic payment in the following example. So there are going to be two parts of this. Let's write the example. You buy a house with a $100,000 loan. And the loan is to be paid off over, that says over, 30 years in equal monthly payments. So we borrow $100,000. This $100,000 is going to have some sort of interest if we're borrowing it. Suppose the interest rate is 6% compounded monthly. So we have a loan and it's 6% compounding monthly paid off over 30 years. Just with this information, we could figure out how much the loan is worth in 30 years. But we're going to ask a little more. You make monthly payments to an account, to a savings account, that earns 6%, same number for this example, interest. And the question will be, how much is the monthly payment that'll pay off this loan? So I'll just say, how much is the monthly payment? So with all this information, there are two things we're being asked here. Even though it may not, well, we're asked how much is the monthly payment, but to figure out what we're paying, we need to, well, figure out how much the loan is worth. So we take out a loan, we're paying off a loan, but in order to pay off a loan, we're paying into a savings account that earns interest. And across 30 years, we're going to want these two values to be equal. So let's start by figuring out how much the loan is worth. So 1, in 30 years, the loan is worth, what is the loan worth in 30 years? Well, here we don't have simple interest, we have monthly compounding, but we can use our interest formula that takes monthly compounding into effect. So A is P I'll use the annual one, times 1 plus r over m to the mt. And with our numbers here, we have 100,000. 1 plus the annual interest rate. Yeah, okay. If it doesn't say annual interest rate, assume annual. It's 6% per year. I probably should have written that. Compounded monthly, so 12 compounding periods per year, raised to the number of compounding periods, times the number of years, 30 years, 12 compounding periods. So there are, what, 360 compounding periods in 30 years. And what does this equal? Well, this is approximately equal to 602,257 and 52 cents. So we have this loan that's worth that much. So we're going to want to make monthly payments into this account so that in 30 years, the account builds to 602,257 and 52 cents. So I'm going to write what I just said in step 2. You need a monthly payment into the account. I'll put that in parentheses, into the savings account. That will build to what? 602. Let's write the right number. Let's write the right number. 602,257 and 52 cents in 30 years. Yeah, sorry, my lines are a little off. The department has not been able to get ink refills on this, so I'm, as in previous weeks, I'm writing on paper without depositing ink on the paper, so I have to remember where I'm writing words. You need a monthly payment into the savings account that will build to 602,257 and 52 in 30 years. Well, we can figure that out using our payment formula from either week 11 or week 12. And what is that? Well, D was the letter we used for it. D equals 602,257 and 52 cents times what? Well, times the annual rate, 0.06 over 12, all over 1 plus 0.06 over 12 to the 12 times 30. And what does this equal? I'll be able to fit it there. Equals 599 and 55 cents. I'll put it on the diagonal so it fits. So a $599 payment, 55 cents, each month will build to that amount. So that answers this question, but I would like you to just note one thing. I'll have to move it on the next page, if it ever gets to the next page. There. Note, so in that example, it may look like you're paying $602,000 for this house, but you're really not paying $600,000 for the house. So note, where did I write note? There we go. You pay out of pocket. How much for this house? Out of pocket do you pay? $599.55 times, so that's a monthly payment, so 12 months a year, times 30 years, and that equals $215,838. So you do pay out of pocket that much across 30 years for this house. That $602,000 that comes up is kind of an intermediate number, an intermediary number, that shows, how much this, well, how much the loan built to, but also how much the savings would have built to. So this last example, I think, is a pretty nice combination of a few of the things we've done.